Hello, myself Nitesh Pradhan from LabVIEW and Multisim. In this session, I will show you how can you find the frequency of your recorded data. So for this session, I will take a small example. I cannot say this logic will be fit for each and every kind of the your experiment, but most of the time, 80 to 90% time you will get your proper answer. So for that, first I will show you my pre-written example. After that, I will write a code and I will explain. So let's start. Okay. Now you can see here. Here I have written one example. Okay. This example is for the signal generation. In this example, I'm going to show you the block diagram. In this example, I am using a basic function generator. Using this basic function generator, I am able to generate a signal, and using this waveform I am plotting that signal, and after that I am using this power spectrum density to find the power spectrum of that particular signal. Then after that I am using the array maximum and minimum to find out the location of this spike. I mean find out the frequency of particular signal. So let's run this program. Now you can see here, when I will run the program, it's generating a sine waveform. I'm going to change the frequency. Now you can see my frequency is near about, let's suppose my frequency is 10 right now. Now you can see my frequency is 10 and I am getting the signal both the side, here and here. If I will reduce it like 20, let's okay 50. So now you can see I'm getting this spike here. I'm getting the spike near the 10. It's indicating my signal frequency is 10. Okay, my signal frequency is 10. Suppose if here I am going to put it 32. So now you can see here I am getting the spike here and my signal frequency is 32. So how I am getting this one, and after that I can easily able to find out, or I can easily able to find that value in my digital display or in the form of numeric. Okay, so for that, here I am using the power spectrum density. And when I'm so here you will get this power spectrum density. You will get this power spectrum density from the signal processing and spectral. So you will get this power spectrum density here from this location. So I am using this power spectrum density. After after the using this power spectrum density, I can see here. hmm, you can see here. If you will right click and if you will create a indicator, so you will find the power spectrum density is giving a data. The power spectrum density is giving a data. Okay, the power spectrum density is giving the data in terms of array. So if the power spectrum density's output is array, so easily we can use the array function palette. We can easily use the array function palette, and we can use the maximum and minimum function, to find the location of this big spike. Okay, location of this big spike we can use. So now you can see here I had given the frequency 100. Now you can see here I am given the frequency 100. So this, okay, frequency 100. So in this location, 100th location, in the 100th location I am getting this big spike. Thus I can easily bring using the array max and minimum. We can easily use. Now I am storing the data. I am storing this data in I am storing in data in my PC, in place of the videos data test, with the name of test.tdms1, test.tdms1, or my signal type is tdms, which I can show you. Look at here. I am using this. Okay, it is my PC video. Here I had created a data. Okay, and the data name is test.tdms. That I had created. Now in the next VI, here you can see here in this VI my block diagram. Here I am using the block diagram. Here I am using this block diagram to read the data, read the text file from the same location. Read the text file from same location, video, data, text file, same location. From same location I am reading the data. Now you can see here my frequency is right now. You can see here the my frequency. Just a second. Let me reduce the size of this. Okay. Now you can see. Okay. Now you can see here. Run the program. The frequency is 100. The my given frequency, my signal given frequency is 100. My given frequency is 100, and the signal is detecting the from generation side. I am detecting the signal 100. Same file, and it is saving the file in terms of the with the name of test.lvm. If I will read, so now you can see here the system is reading that particular file, and my signal frequency is 100 here. Suppose here if I will give the 1 2 3 1 2 3 4, the frequency is 1 2 3 4. If I will run, so easily I will get the signal, and here using this I can read the signal with the name of 1 2 3 1 2 3. So in the first example, let's try to change the signal type. Here I'm going to change the signal type square signal, and here I am going to change the data file name test.2, test, sorry, test2. Okay, test2 I had created here. Where I am creating this test2, I am creating the test2 here. After my when I will run the program, now you can see here the it is generating the test2. It's generating the one more file test2. Test2 is generating, and signal type is square wave. If I will reduce the signal 20, so we'll get the square wave. Now you can see we are getting the square wave. Okay, now come here, come to this signal and run run. Here I am not getting this same data. Why? Because here I am still reading, the my stored data. Here I am still reading my stored data. So let's try to change it. If we'll change the stored data, so like this, I am taking the test2 m, and I am using this data test2. So now you can see if I will run the program, so also I will get the 20. Also I am getting the 20. So in place of this, let's take one more waveform graph that will show me the particular signal which I am reading. So using this, I can read the particular signal. Okay, just a second. Using this, I can read the particular signal. And one more thing, let me check. Convert into the controls. So using this, I can change my controls. I can change the signal type. Now from here, I am going to change the signal type. Short triangular signal. Run the data. Now you can see it's generating triangular signal, and we are getting the frequency 20. Same if I will try to read. Now you can see we are able to read our stored data, and we are easily able to get the frequency. So how I am getting the frequency? I am getting the data, and after that I am using the conversion from dynamic to convert to the dynamic data type. After that I am taking the power spectrum density, and after that, after using the power spectrum density, I am displaying the data using the waveform graph 3. Here I am using the array minimum to maximum, and in this array minimum to maximum, okay, if you will press Ctrl S, so you will get to know array minimum to maximum function will take the array, and it will show you the max value and index of max value, minimum value and index of minimum value. So we have to always find, you have to always take the max value index. That will be our frequency for our signal. That okay. So same here I am using. Suppose if I will write it 200, frequency is 200. Suppose if frequency is 200, and I am writing the data, so you can see here, and frequency, so same signal I will get here. So using this program, you can easily able to break out, and you can find your signal frequency, and using this program you can easily get the signal frequency of your stored data. Okay, so thank you for watching this video. I will try to write a program where I will try to show you how can we get the signal frequency of our any specific particular song.